Today we will learn insertion sort. So insertion sort is something like we have some unsorted list, unsorted numbers, and we have to sort this using the insertion algorithm. So now let's see how we can do that. So first let's understand what is insertion sort. So here you can see 11, 4, 22, 25, 34 to 90. So this 2 should be in the first part, and then 4, then 11, then 22, then 25, 34, 90. So while sorting these numbers, we can do a specific way, and that way is called insertion sort. Let's see what is that way. So first we check 11. This is the first index, so we will start with the second index. So we'll check 4 is bigger than 11 or not, right? So 4 is bigger than 11 or not. Yeah, 11 is bigger, 4 is smaller. So 4 should be in the first index, when the previous index, right? So the 4 will be there, 11 will be in the second index. Okay, then these two parts sorted. Then we go to 22. So 22, is that smaller than 11? No. Okay, sorted. 25, is it smaller than 22? No, it's sorted. 34, is it smaller than 25? No, sorted. 2, is that smaller than 34? Yes. Okay, so 25, is it smaller than 2? Yes. Okay. 22, is it smaller than 2? Yes. 11, is it smaller than 2? Yes. 4, is it smaller than 2? Yes. Then 2 is in the right position. So in this way is sorted. And then finally 90, is it smaller than 34? No. So sorted. So this is actually called insertion sort. Now let's implement that using Python. Here you can see a list containing 11, 4, 22, 25, 34, 2 and 90, and we have the function called insertion sort. So let's make that insertion sort function. So first we will pass the list, this list, through here. So it should be array, and then we have to do make a loop. For example, like a loop. For example, 2 want to come here, 2 want to change its position from here to here. So need to make a loop so we can like change one by one. So for making a loop, as we have already said, it should be start from 1 to the length of array. For simplicity, let's print that. So this is 1 to 6. This is the index, like 1, 2, 3, 4, 5, 6. And if we use the index in the array, then we can check the numbers like 4, 22, 25, 11 is missing, right? So we have to also mention the 11. So we will call that previous index, which is I minus 1. That means 11. Now if we print the previous index and the numbers, let's see. I mean, it shouldn't be index, it shouldn't be I, it should be index, right? So now we can see the previous index 0, 1. So we can also see the array format, the actual value. Now we can see 11, the previous index and previous value, 11, 4, 4, 22, 22, 25. So we can see the previous part and the previous value and the next value. So now what do you have to do? So let's clear it, that print. We have to make a key. Why we need key? For example, when we exchange position like 34, 2 and then because 2 should be checked by 34 and then checked by 25 and checked by 22, right? So when they exchange the position, then we must need a key. I'll explain you later why we need the key. So let's first make the key. Basically now the key is the value of that index. I mean this number like 4, 22, 25, this one index. Now if we consider about this place, what we need to do when the index come to 2, for example here, this part we will consider about this part. So this part needs some kind of loop, right, from here to all. Like this 2 should be compare all of this, right? First 2 will compare 34, 2 will compare 25, 2 will compare 22, right? So now we need a loop, kind of another loop, right? So we make a while loop and we said previous index. For example, this one. If the index is 4 and previous index 11, so previous index greater than equal to 0, and the key, the number 4, is smaller than the previous index value, for example 11, right? So what we are saying here, until means until it becomes 0, the index becomes 0, and the value of the index and the value of the previous index, the is we can see is like smaller. If this one is smaller than this one, in that case we have a loop, and we have to terminate the loop. For that case, I'm making previous index minus equal to 1. It will decrease the previous index by 1. Now I have added 2 prints so we can see it clearly, okay? So when you run, let's check the results. The index 4, we start from here. Previous index 11, previous index 11. Okay, finish. So this loop is finished. 1 is 4, this just go to 1, because 4 is smaller than 11. Then index 22, previous index we can't see because the condition in the loop is not true, so it doesn't run this part. 25 also same, 34 also same. But when it comes to 2, when index is 2, we can see this loop works because this condition matches. So previous index become 34, you can see previous index here, previous index become 34, and then second loop previous index become 25, third loop previous index become 22, and the fourth loop 4, and the last loop is 11. So this is the thing happen. And when it's come to index 90, it doesn't have because the condition does not match. Okay, we got it, right? So now when there is a loop, we have to do one more thing. We have to exchange their positions. Like when previous index is 11, like when this loop works, in this loop we have to do something. We have to change 4 should be in 11's place and 11 should be in 4's place, right? So first we took the key, right? Why we took the key? Okay, let me explain you now. So here you can see array of previous index plus 1. Previous index is what? In this 2, index is 4, previous index is 11, right? So previous index plus 1 means this place. So in this place we are inserting previous index, that means 11, right? So in 4's place we are putting 11. Then where is 4? So we also need to put 4 in 11's place, right? In that case we have the key. We put the key, and in that key we have that 4. So now what you can do, in the position of previous index, array of previous index, we'll insert key. Key is 4, right? But in this way we have a problem. So let's see what is the problem. We run it. Before we run, we just check the whole array. After finishing everything, we can check the array, and let's see what inside the array now. We can see 2, 4, 11, 22, 25, 34, 90. Everything is sorted well. So till now our sorting algorithm is finished, and the problem I said I will discuss it with the next video.